Hello students, in this session we will discuss about linked stack. A stack data structure can also be implemented with the help of linked list. Now such a representation is known as linked stack. Here now it shows the diagrammatic representation of a linked stack. So here start and top are two pointer variables that points to beginning and ending nodes of the stack. Now you are familiar with stack concept. So stack always associates with a term called top, where this end allows insertions and deletion operations. So in stack point of view, insertion and deletion operations are referred as push and pop operations. Here observe insertion operation. So algorithm push of item. So this procedure inserts a new element item at top position of the stack. Now this algorithm, step 1, allocate memory for a new node. Data of new equivalent to item, link of new equivalent to null. Step 2, if top equivalent to null, that means elements are not available at this stage, start and top both points to new node. Else, now we establish links in between top node and new node as link of top equivalent to new, top equivalent to new, and if. Now return from the function. Now deletion operation, algorithm pop. So this function removes the topmost element from the stack. So step 1, if top equivalent to null, that means elements are not available. Hence we print a message as stack underflow, return -1. Else, first to access the data part of top end, like k equivalent to data of top. If start equivalent to top, then start equivalent to top equivalent to null, return k. Otherwise, else, now ptr equivalent to start, temp equivalent to top. Repeat while link of ptr not equivalent to top, ptr equivalent to link of ptr, and repeat. Now top equivalent to ptr, link of top equivalent to null. Release memory of temp, return k, and if, and if. Okay. Now it's way of printing elements of the linked stack. So algorithm display. Now this procedure is used to print elements of the linked stack. So step 1, if top equivalent to null, then print a message as write linked stack empty. Else, first one, temp equivalent to start. Repeat while temp not equivalent to null, write data of temp, the temp equivalent to link of temp, and repeat, and if. Now return from the function. So this one, linked stack. Next concept, linked queue. Now as similar to stack, queue data structure can also be implemented with the help of linked list. Now such a representation is known as linked queue. Now it shows a diagrammatic representation. So here front and rear are the terms which are always associated with queue data structure. So here linked queue starts at front and terminates at rear end. Now observe these operations. algorithm insertion of item. This procedure inserts a new element item at rear position of the linked queue. Step 1. Allocate memory for a new node. Data of new equivalent to x, link of new equivalent to null. If front equivalent to null, then front equivalent to rear equivalent to new. Else, link of rear equivalent to new, rear equivalent to new. And if step 3, return. Now deletion operation. Algorithm deletion. This function removes the front position element of the linked queue. If front equivalent to null, then return -1. Else, now k equivalent to data of front. If front equivalent to rear, then front equivalent to rear equivalent to null. Else, temp equivalent to front, front equivalent to link of front. Link of temp is filled with null pointer. Release memory of temp. And if return k. And if. Next operation, algorithm display. This procedure is used to display the elements of the linked queue. Step 1. If front equivalent to null, that means elements are not available. Hence we print a message as linked queue empty. Else, now elements are available. First set a temporary variable that points to front node. Now is a repetition process. Repeat while temp not equivalent to null. Write data part of temp, temp equivalent to link of temp. And repeat. And if, now return from the function. So this one, linked queue. Thank you one and all.